Hello, today we're going to be looking at special products of polynomials. There's three special products we're going to look at. There's really two. One's just a little variation. And when we're doing this, even if you don't learn anything today, you should remember foiling. The idea today is we want to get you to look at some special cases where we're multiplying binomials and notice the pattern and go straight to the answer. The first one is a sum and difference pattern. What I mean by a sum and difference pattern is if I'm multiplying two binomials, in the first binomial I'm adding, and the second binomial I'm subtracting, that's what we call a sum and difference pattern, because the first one is adding, the second one binomial I'm subtracting, hence sum and difference. And what this turns out to be is a squared minus b squared. When we were doing the problems in class, some of you found this by accident, actually by doing the FOIL wrong. That is, when you distributed twice, you did it incorrectly, but still came up with this answer, because when we do the outside and inside from FOIL, or when we distribute, those two terms cancel each other out because one's positive and one's negative. In terms of words, what it is, every time I have a sum and difference, it's the square of the first term minus the square of the second term. Pen didn't quite work there, so we'll try it again. The square of the second term. And so if I look at it up here, a plus b times a minus b, the first term is a, so I'm going to square that, hence a squared. I'm going to square the b, and then minus b squared. That's all I have to do. So if I look at the first example here, I've got a sum and a difference. One time subtracting, one time adding, one time adding, one time subtracting, doesn't matter. So I square the first term, that's 9b squared minus 25, because I square the 5. That's all I do. Now, the square of a binomial pattern, we have two of them we're going to look at. First off, we'll talk about a sum. So if a plus b squared is not a squared plus b squared, you cannot distribute the exponent across an addition sign. What it turns out to be is when I do my distributive, a plus b times a plus b, notice I get a squared plus ab plus ab plus b squared. Or when you FOIL it, you'll get that. So I get a squared plus 2ab plus b squared. And that's the pattern we're going to look for anytime you see a binomial squared. So what I'm going to do here is, let's put this in terms of words. So what I'm going to do is the first term squared plus double the product of the terms. Plus the last term squared. So if I take a look here, a plus b squared, the first term is squared, so a squared. That's where I get the a squared from. Double the product of the terms. So I go inside the parentheses, I take a times b, and I double it, and that's where I get to 2ab. And then plus b squared. Of course, all this comes from just distributing the problem. Now the other square of a binomial is what happens if I minus. So a minus b squared. Well, remember, that's a minus b times a minus b. Well, that's a squared minus ab minus ab plus b squared. Plus b squared because a negative times a negative is a positive. So it's a squared minus 2ab plus b squared. So it's almost the same as the first one, but notice when I'm adding, there's a plus sign. When it's minus, there's a minus sign for the middle term, but never the other terms. A is always squared, b is always positive. So we're going to say the same thing. I'm just not going to write it down. Well, what the heck, I'll write it down. It'll be the first term squared minus double the product of the terms doesn't like my H's for some reason. Plus the second term squared. So notice the first and last term are always positive. The middle term is a negative when I'm subtracting the square of a subtracting binomial and adding when I have addition. So let's take a look at an example here. Here we go. This is what I was talking about. So I'm not going to show any work. I'm just going to use what I know. 7a plus 2, the quantity squared. Well, the first term is 49a squared. Since there's a plus sign here, plus, double the product, 7a times 2 is 14a. Double that, I get 28a. Plus the last term squared is 4. Now, let's take a look at number 16. It's almost the same thing, except notice there's a minus sign. First term squared, 4p squared. 2p times 5q is 10pq. Double that, 20pq. Since I'm subtracting in the binomial, my second term is subtracting, plus 5q squared is 25q squared. Now, number 18. Why are we going to have to use this stuff? Well, remember, polynomials are just a way of representing a general rule for adding. So if I want to take 19 times 21 in my head, well, that's kind of hard to do in my head. 19 times 21. Here's what I'm going to do. I'm going to think of 19 as 20 minus 1. I'm going to think of 21 as 20 plus 1. I have a sum and difference there. So it's going to be 400, first term squared, minus second term squared, 1. So 399. Should be able to do that without your calculator. Hence the word mental math. You don't even have to write this stuff down that I did here. You could go straight to the answer because the idea is to mentally, but we want to show how we're doing this. That's why I put it in there. Now, 38 squared. Now, 38 is pretty darn close to what numbers can we square in our head. Now, we can do this a couple different ways. I can do it as subtraction, or I can do it as addition. Now, to me, I can add a lot easier in my head than I can subtract. But I can do it both ways. So I'll show you both ways. So 38 squared I can treat as 30 plus 8 squared. Because I want nice numbers. Now, do I know 35 squared in my head? No. Do I know 38 squared in my head? No. I know 30 squared because that's 900. So 900 plus, think in my head, 30 times 8 is 240. Double that, I get 480 plus 64. So then 900 plus 480, I can do in my head, that's 1380, plus 64. Now that one's not so quite, it's not so easy to do in my head, but it is 1444. Just got to remember 8 and 6 is 14, so you carry the 1, so you get 1444. Now, if I would have chose to do it as a subtraction problem, 40 minus 2 squared, well, that's 40 times squared is 1600 minus 40 times 2 is 80, 160 plus 2 squared is 4. Now, in my head, I'm going to take 1604 minus 160. So 1604 minus 160, if I just think, well, geez, what's that answer? The same answer, 1444. Now, I just think adding is easier, but if you're good at subtracting, you can do subtracting. Either way would work out. And that's it for special products.